Hi, good evening. And tonight I'm going to do some electroplating of copper. So I'm going to very quickly go in and show you that. In fact, I've got instrument in front of me, essentially a potentiostat, but we can call it a power supply. I've got some electrodes that I'm going to electroplate onto the the cathode, which is my working electrode. So I've got some of these in front of me, and you're going to see me do a live electroplating onto these very shortly. You're also going to see that I've got a microscope in front of me, so I'll be able to show you the electroplating kind of progressing as we go along. In fact, I've got my phone here because my phone's going to be controlling the experiment. So hang on there while I'll set this up and we'll see the experiment. But I just want to kind of give a quick intro. So as I say, I want to show you that we've got hardware here. We are going to do a demonstration in a minute. So I'll take that screen printed electrode in that particular case. I'll just put the electrode into the potentiostat, or the power supply is all it really is in this particular case. And you'll see me put a solution of copper sulfate onto the electrodes. So you'll see me deposit that 50 microliters shortly, and then you'll see me do these settings where I'll run this experiment for about 240 seconds. I'll apply a voltage of about 700 millivolts, and I'll just hit the measurement, and then we will be doing the deposition of copper. So let me go ahead and do what I just sort of described. So I've got my screen printed electrode over there, which are my electrodes. I'm going to grab, I might just slide that underneath here because I want to kind of essentially film that. So let me just show you, if I just go to here, you can see underneath my microscope, and in fact there's the electrode there. So there's the electrode, and I will put the 50 microliters drop onto that now. So I've got my copper sulfate here. This is what we call 50 milligrams per milliliter. I think that's 50,000 ppm. I've got 50 microliters. There's a lot of 50s in this statement. So you can see my my solution's going on like that. I'll just change for a second. So you can see my setup is down there, and I just want to show you that I've got all this set up on my phone. This is how as I had it on the screen earlier on. I'll just go start measurement, and off it goes. So now what's happening is I'm applying minus 700 millivolts to the electrode, and as you're slightly sort of obscured because I've obviously got the USB microscope in front of me, but what I'm trying to do is deposit copper onto the electrode. Now in real time, if I just go to here, I think I can actually start to see so the emergence of some copper here. In fact, yeah, definitely see the emergence of some copper here. So what's happening is copper is in the solution and it's starting to deposit onto the electrode. Now what I want to do is just talk you through what we're actually seeing here. So what we're seeing is we're waiting for or at the moment we've got this deposition of copper. So what's happening is we've got this electrode. It's sitting in a solution of copper ions. This particular is copper sulfate. And when this now we're applying about minus 700 millivolts, and that means that copper ions are near the surface, and they'll pick up electrons and they'll actually form copper metal. Now there are more ions in the solution that will also make their way to the electrode, and when these do, these are also picking up electrons as well, and they will become copper metal like this. I just want to kind of go back and have a quick look at that. So yeah, you can see now it's almost like it's definitely in real time that actually you can really see the copper starting to be deposited. Now I set this up to run for 4 minutes, which is maybe slightly, I wouldn't say an overkill as such, but you get an early sense of this. So this is not it's quite a good experiment for doing probably in, I mean, almost in schools. It's kind of intrinsically safe. Well, no, sorry, it's safer because we are using things like 50 microliters, which is really just a drop of solution. So it's very kind of small scale. We're applying very small voltages. There's not large power supplies here. There's nothing more powerful in this experiment than a sort of USB-C power supply. So it's got a kind of lot of intrinsic safety about it. I could actually reuse this electrode, and I may do a separate video about that as well. But in real time now, we're about, I'll just show you my phone for a second, just so you can get a sense of this. So this is the sort of macro view, and I can see the time sort of ticking away down there. So we've got about a minute left, and as I speak, we're actually busy depositing copper. So I'll just take you back to that. Sorry, go back to here. And then that's kind of, that will be dramatically different now than when we first started this video. So you can kind of rewind it and see. So this is quite nice because I think often people are sort of doing this on a much larger scale, and they're kind of running this for 5 minutes, and they can't see this event happening in real time. But of course, when you do it on this scale, because the solution is quite thin, let's say, or small, we can look through it quite nicely with a microscope and actually see the process going on in real time. Now, and also we're kind of benefiting from the fact that copper has quite a distinct color associated with it. You kind of get this orange. So when we first started with this experiment, it was a very black, but now it's actually going to orange. So I might just give you a sense of what we've actually been seeing here. So this is really in a copper plus 2 electrons at this cathode is giving us copper metals. Now this is a new type of video from Zimmer Peacock. So if you find it useful or you want us to expand upon it, please don't hesitate to reach out to us. I might just finish with a final shot, and that's the final solution there. I might just take off some of that solution just so we can have a quick look at what's going on there. And then we can see the copper now on that electrode, and if I take it out, I'll be able to see it. So if you have any questions, don't hesitate to reach out to us. Okay, thanks very much.